Okay, today is 9.7, and basically we're in rational functions. This is a rational function right here because it's a fraction function. And I've got a favorite saying of if you can factor it, you should. And it helps again because it shows me that the thing on the top and the thing on the bottom actually can end up canceling. That creates a what? A hole. All right, and it's not the bigger on top, bigger on bottom, same on both things. That's different. It's just that something cancels. And if something cancels on the top and bottom, it creates a hole. Where is the hole at? It's at whatever makes that 0, which is x equals -4. Raise your hand if you had that part right. Awesome. The next part is the domain. Always start with it's all real numbers. You can write a big R or you can draw a number line and fill it all in because everything works on these except whatever crashes it. What crashes something like this? Well, a -4 crashes it because when you put that in, the bottom becomes 0. So there we go. There's two ways to write it. What did I just do wrong that's really common? Yeah? Yeah, I should say not equals -4. Good. So this way to write it is okay. That way to write it's okay. They're just different representations of the same domain. Domain means what works. Everything works except -4. Please explain to me. M, S, why can't -4 work? When I put it in the function, what happens? False. You're close. It makes what? 0. Yes, it's undefined because it makes which part of the equation 0? The denominator. It's not because the top becomes 0. 0 is not a problem. It's only if the bottom part is 0. The top can be 0, bottom can't be. All right, and last thing. Vertical asymptotes. They're these things. The things that crash your function, they make vertical asymptotes. So why can't I say that x equals -4 is my vertical asymptote? Because that spot is making a hole. If it's a hole, we already determined it's a hole. So it can't be an asymptote. So you make your list of things that don't work. And those things either are holes or asymptotes. And in this case, there was only one of them, and it was a hole. So there are no vertical asymptotes. Now, what did we just learn about? Not verticals, but horizontals. And who tells us about them? Bob. And is this one a bob? Is it bigger on the bottom? No. Is it bigger on the top? No, it's not. Remember, it's all about the degree. Degree 1, degree 1. They're the same on both. So if this one's a sob, do you remember when it's a bigger on the bottom, it's a bob, and therefore y equals outside, because bob's an outsider. But this is not a bob. It's not a bigger on top either. If it was a bot, then the thing is no bot. Remember? Like robots, they're going to take over the world. Anyway, no bots. And then the last one is if it's a sob, which is this one, then they're the same on both, and they will make you sob because they're hard to remember. It's a ratio, and it's a ratio of the lead coefficients, 2 and 1. Y equals 2 over 1, so y equals 2. I know the question never even asked that, but I just know you're going to need to know it. So, oh, does your slide have it? Okay, awesome. I would say, what is the horizontal asymptotes? And then you would say, okay, horizontal. That's the horizontal asymptotes. Those are the y equals things. And then you're like, y equals, oh yeah, that's right, this is the Bob ones. Bob tells you why. Bob's a very deep guy. He'll tell you why. All right, this one. Remember the whole outsider thing? Do you have this slide? Yeah. Excellent. Find me the verticals, the horizontals, and the domain. And there is no hole. I'll tell you that right up front because there's nothing that can cancel, right? So there's no point in looking for the hole because there isn't one. See if you can find the domain, the verticals, and the horizontals. I'll pause for a second while I give this a shot. Okay, so here's what you should have done on this one. First of all, I hope you get that 3 would have caused a problem. So the domain is all real numbers work except for x cannot be 3. Not -3, sorry, 3. Raise your hand if you had the domain right. Okay, good. The next part is the verticals. That 3, this is either a whole or it's an asymptote. So since there's nothing canceling it, it must be an asymptote. So it's x equals 3. Raise your hand if you had that one right. Come in, never raising your hand. Do you have these right? Okay. All right. And the next one is the horizontals. Who tells us the horizontals? Bob. Is this actually a Bob? It is a Bob. It's bigger on the bottom because it has degree 1 on the bottom. And therefore, if it's a Bob, then what's the deal with Bob's? He's an outsider. So it's y equals 0. But in this case, there's something on the outside. So y equals 0 plus 2, which makes it what? 2. Now, do you get why this is? If this was a parent graph that looked kind of like that, it got moved. What's this again? Right 3. Oh, wait a minute. I messed my head up because there we go. Right 3, right 3. And then it also got moved where? Up 2. Do you get why the horizontal asymptote didn't move until now? And now the horizontal asymptote, which is this guy, runs through there right at 2. See, that's why we need to do it that way. Okay, so horizontal asymptote is at y because it's a horizontal asymptote, remember? And what are these verticals really? Verticals, good. Y equals 2. Next slide, that one. Factor it. Domain. The verticals and the horizontals. Figure them out. Remember that when stuff cancels, it leaves behind a 1. Okay? Do this one. I'll pause for a second while you try this. We're back with, hopefully, a factored base. It's all about the base, of course. There we go. And that gets canceled, right? All right. Then what did they leave behind? 1s. So it's really 1 over x minus 3. Now what does that do? That creates a what? A whole. And I go down here to the whole category. And what was the whole? The thing that was making that 0. So x equals negative 2 is an important thing. And x equals 3 is another important thing. And those are both the things that would crash my function. So it's all reals except x cannot be negative 2. X cannot be 3. And those are either what's or what's? Vertical asymptotes or wholes. And one of them is a whole. That one's the whole. And that one's the VA. Okay, so this one's x equals 3, and this one's x equals negative 2. That leaves me the horizontals. Who tells me the horizontals? Bob. Is this a Bob? This is a Bob because it's got a bigger on the bottom down there, and if we know it's bigger on the bottom, then there's outside the function is what tells me the answer. There's nothing outside the function, so it's y equals 0. Good. All right, the verticals are the ones that come from the base. These guys, the things that make the base 0, those are the ones that give you the verticals. The horizontals are the ones Bob tells you. Okay, the one that cancels on the top and the bottom, that's the whole. If anything will cancel, that's creating a whole. Yes? You can have a vertical and a whole. They just can't be at the same place. Okay, so this one was the whole, and this one's the vertical. All right, one more. If you can't factor it, you should. Yes, sir. Oh, okay, good question. Let's do that on this one. I think this one's also going to have a whole. So we'll find the y value of the whole for this one to show you how that works. Oh, I bet you can factor it. You sure? I'll give you a hint. If you were going to factor it, it would have to be a 2x and an x. And the two things that are here and here would have to multiply to negative 3. See if you can find it. It's possible, it might not be factorable. We'll usually set these up so it can be factored. So I would bet you if you try, The outside and the inside also have to make negative x. That's another critical part. I'll pause for a second while you try that. Okay, did you factor the top, or was it not factorable? Somebody find it? Raise your hand if you found it. It's only about half the class. All right, it was tough, but here's some hints. If the two question marks have to be something that multiplies to -3, that really narrows it down. It's got to be a 3 and a 1, right? It's just a matter of where the 3 and the 1 are and whether they're negative or positive. So this is where everybody gets bogged down. They know it has to be a 3 and a 1 if they got, you know, half an idea how to factor. You know it has to be a 3 and a 1. But then which one is which? You just try it and see if it works. You know it's got to be 2x and x, and you know it's got to be a 3 and a 1, and I don't know if that's the right way or not. And I guess whether or not it's positive or negative, I'm honestly, I'm just totally guessing here. And now I'll try it. And I find out. The outside and the inside make, in this case, positive x. Crap, that's exactly the opposite of what I wanted. So then I just got to do what? Switch the signs. What if I had been way off? Switch the numbers. That's the key about factoring. All right. So since I just have to switch the sign, the plus becomes a minus. Minus becomes a plus. And now outside and inside ends up with a negative x on the inside, and we're good. It's factored. And what's another hint? It's probably going to want to cancel that. You get how I kind of probably guessed it was x plus 1? All right. So anyway, if x plus 1 and x plus 1 are going to cancel, that leaves me with a new equation where there's a 1 on the bottom. And it's, if I rewrite this to make it cleaner, y equals 2x minus 3 over 1. Why does that matter at all? It doesn't until the very end. This is still all reals except x cannot be, what are the things that would can't crash my function? Can't be -1. Nope, there's only one thing on the bottom. Don't think about the top. If the top becomes 0, it will not crash. 0 on top's okay. It's just 0 on the bottom. All right, so it's just this. Then this thing is either a hole or an asymptote. Which one is it? It's a hole. So if it's a hole, it's at x equals -1. Now, some kids have asked me, would you tell us how to find the other part of the hole? Sure. If the x is -1, do you get that has to go with some y? All you have to do then is to take this number for x and you stick it not in the original, because you get if I put in -1 in the original, it's going to crash it. So it doesn't make any sense to stick -1 in that. It'll crash. So you stick the -1 into this. And you put the -1 in for x, and you would end up with 2 times -1 is -2 minus 3 makes -5 over 1, which is -5. That's why the hole would have been at -1, -5. And again, I've already had arguments with teachers about this, not arguments, not like mean or anything, but they're saying like, well, then if there is a hole, then you're saying that there is nothing there. So then why are you making them show you where there's nothing? Which you could argue that. Okay. But the point is, everybody agrees as math teachers that x equals -1 is important to know. You have to know where the hole is for the x. But whether or not you have to find this y kind of depends on the test and on the teacher. In calculus, they're never going to ask you for that y. But in this class, we might. So you got to be ready for it. So let's go back one slide. Everybody go back to this green one. I haven't finished that yet. Okay, I guess I should finish the vertical first. So the vertical is the zertical, and that's whatever wasn't a hole. Well, but the only thing we had that crashed it was a hole. So you tell me. None. Because we take whatever's here, and if it's a hole, then it's a hole. If it's not a hole, then it's an asymptote. But there was only one thing, and it was a hole, so there's no asymptotes. Now, how about horizontally? Horizontal is told to us by Bob. Is this a Bob? No, it's not bigger on bottom. What is it? It's a bot. What's the rule for bots? No bots. And therefore, it's no. Or none. The ratio one is if it's a sob. Same on both. All right, so now I'm going to go back a slide. Everybody go to this green slide, please. Now, I know it's really, really messy. I'm going to clean it up. After we had, don't talk now, please. After we had this simplified down to just the red right there, and then we canceled something. Remember this? We had it factored, and then we canceled this. Do you get what's left is that? It's y equals that. Y equals 1 over x minus 3. So then, if our whole, in this case, was at negative 2, then the whole was really at negative 2 comma what? Don't say it. Figure it out. Mr. O.M., tell me where to put that negative 2. Do you know? All right, pay attention. It's MM. Don't know where to put the negative 2? Okay, where? There it is. You put the negative 2 in right there. So that means 1 over negative 2 minus 3 makes negative 5. So 1 over negative 5, and that's your answer. The whole would have been at negative 2 comma negative 1/5. All you got to do is take the x of the whole and stick it in the equation. You really can't screw up too much, because if you stick it into the original equation, it's just going to crash, and you're going to go, oh, that's right. I can't stick it in that equation. You have to stick it in the other equation, the one where the whole has already been canceled off. That equation. That's the one you stick it into. All right. Now let's go to the slide. It's green again. It's pretty intense looking. That's about as complicated as they could get. So give that one a shot. I'm going to pause. We'll give that a try. Okay, so we're setting up the factoring here, and we figured out that the top factors to x minus 3 and x plus 4. And oh my, there's a lot of things that are going to cancel in, isn't there? As I look at this big fraction, I can cancel off that, and I can cancel off that. That means this is a wholly function. It's got 2 wholes in it. Okay? So all real numbers except x cannot be any of those 3 things that make it crash. 2, x cannot be, wait a minute, cannot be negative 4, and x cannot be positive 3. Raise your hand if you had that part right. All right. The next step, vertical asymptotes. Those are the ones, either these things are wholes or asymptotes, one or the other, and 2 of them are wholes, but that does still leave that guy, and that one's an asymptote. X equals 2 is the asymptote. How about the horizontals? Who tells us about those? Bob, and is this bigger on the bottom, bigger on top? Is there on both? Bigger on the bottom. If you multiplied this all the way out, you'd have x to the 3rd on the bottom, and so it's a Bob. What's the rule for Bob's? Y equals what? Is it always y equals 0? It's whatever's on the outside. So there's nothing on the outside of this fraction. Y equals 0. Like y equals nothing. And then the last thing is the whole. Well, there's actually 2 of them this time, because the x minus 3 canceled the x minus 3, and that means x equals 3 makes a whole. I know I can find the y of it in just a second. And then the other one is x equals negative 4. Do you get that that means that there's a whole at 3 comma something, and there's a whole at negative 4 comma something? Would it make sense to stick them in the original equation? No, because that would make the equation crash. And so if I don't want to stick it in the original equation, I better rewrite what's left after all this stuff canceled. That canceled, and that canceled, and that canceled, and that canceled, only leaves this. So is it nothing over x plus 2? That wouldn't make any sense. 1 over x minus 2. And then I can stick the numbers in that. So if I want to stick in a 3, see, for this, that 3 goes in here, and it's 1 over 3 minus 2, which is 1. 1 over 1 is 1. How many of you could have gotten that part? Okay, good. And the other part is negative 4 goes in there. Negative 4 goes in here. And I have negative 4 minus 2 is negative 6. 1 over negative 6. 1 over negative 6. Those are the exact spots where the holes would be. Okay. So that's pretty much just a review. So then we need to touch that one thing that we didn't learn yesterday, which was about what if I give you an equation that's got a hole in it, or no, I'm sorry, what if I give you a graph that has a hole in it? How do you tell what the equation is for that graph? All right, so imagine for a moment that this was the graph. You're on your test, and you're like, okay, so I'm supposed to give an equation for this. It's got a hole at, let's say that hole is at 2. Do you get this has to have a y equals, and it has to be a fraction function to have a hole at all? I encourage you to not start with the hole. Do the hole last. What we need to figure out is if it goes through the y-intercept of 2, do you get that this equation has to have a x plus 2 in it, sort of, except I got to figure out the slope. What's the slope on this guy? It's kind of hard to tell. It looks to me like it rises 1 and runs 2. Do you get that that's my equation for it without the hole? Rise, run, y-intercept. Then you just have to put a hole in there. So you go, okay, so now it's a fraction. That's part of it. That's part of it. That's part of it. And I got to get 2 to make the hole. So I go x minus 2 and x minus 2. I'm going to give you another one like that. See if you can handle this. I don't know. Pause for a second while I design this nicely. Okay, so here's my equation. Now, here's my graph. You write the equation. My first thought is try not to even look at the hole for now. If you can't write me an equation of a basic graph, you've forgotten an important thing out of algebra. Slope-intercept. I can tell the slope of this. I hope you can. I can tell the y-intercept. I hope you can. You can write the equation then. I'm going to pause for a second while you try that. And I'm going to have you compare with the person I pair you with. Okay, so I heard a bunch of people comparing. That's good. Y equals mx plus b is the general form. What's the slope in this one? 2. So 2x. And then the y-intercept is 3. 2x plus 3. That's a really good start. Now I just need to have an extra hole in there. How do I put the hole in there at 1? Well, if there's a hole at 1, then that means 1 makes the hole. So x minus 1 and x minus 1. Raise your hand if you had that one right. Okay. If you figured it out now, that's good. Yes? You're not supposed to what? Nope. Think of it this way. This is not one of those kinds of problems. And what we were doing before was just a simple equation. Y equals that right there. That's back from algebra. You learned it a long time ago. Do you remember that there's no inside and outside on these? It's just you got a plus 3 there. That's because of y, because it's a y-intercept. And you got a 2 there because it's a slope, and that's how steep it is. It's based on how much rise and how much run. That's how you make that part. Then the rest of it, you just have to put in your top and your bottom part of the hole. All right. I think that's enough of that. Your assignment is the normal assignment that you would find. And I'm assigning I'm going to just say it's the even problems and the even letters of problems. So if you're on problem 3, do you get to skip everything if it's got multi-parts? Nope. You get to do the even problems and the even letters. No letters? Keeps it simple. Do the evens. Don't stress. It's not that. All right.